GHC.
Here we are. So this is hopefully sort of nice and interactive. We will finish, in 25 minutes flat. I'm going to tell you about the things that are kind of interesting and ongoing, and give lots of credit to lots of other people, I hope. So first, little bit of so please ask questions and make comments as we go along. We will finish. It'll be more fun like that. So let's see. Just a little sort of backing up a bit on what have we released so far. So GHC 8 came out this a year and a half ago in January 17. It was really a big release. There was a lot of new stuff in GHC 8, largely. There's a sort of long list here, particularly this type-in type stuff, to which I'll come back to. And it has really taken a long time to get all this stuff settled down. In fact, GHC 8.2, which was 6 months later, was pretty much a sort of consolidation release on that. There was some quite significant new pieces in GHC 8.2 as well, but not on the same scale as before. So this is really a slide from last year's. This was more or less what I was advertising last year. Then 8.4 came out in March this year, and was more consolidation. Particularly on type in type. Ryan continued, if I had a pound for every ticket and patch that's to do with deriving, which when we designed it in Haskell was a very small feature, but Ryan has made a career out of doing amazing things with deriving. It's very impressive. More semi-group stuff and performance improvements, particularly for large projects. This came out of Simon's team at Facebook largely. So 8.6 has at last, finally been released. Thank you, Ben. More consolidation. Ryan has been working on coverage checking. There's quite a lot of better optimization stuff. Thank you, Joachim, on exitification. Those of you who've been following the stuff about join points. Join points have proved a nice point of leverage. There's some very nice stuff work there. Not complete, incidentally. Ryan, Joachim, where are you? Yes, you see you've been sucked up by Definity. I want to finish off this recursive business. Code generation, block arguments, plugins and recompilation checking. But so quite a few sort of filling in stuff here. A couple of quite significant new features. One is quantified constraints, which I advertised last year. And I've been advertising it every year in this talk, but nobody was rolling up their sleeves and doing it. So finally I did. I'm very excited about it. It was a nice paper by Tom Schrijvers and his colleagues in Haskell 2000, last year, in fact. And then some, Iceland Jack and other people who torture type systems have then done totally amazing things with this and pushed this stuff in directions I had not really anticipated. But it seems to be working quite well. So have a go. Look, what's the idea? If you've got rose trees, which are parameterized over some higher kinded thing here, and you want equality on them, well, then we're going to need to be able to take equality on this component of the pair. But how can we take equality on those? Because it involves a call of f at some other type. So what you really need to know is that f has the property that for any b, if you have equality on b, then you have equality on f of b. And that's what quantified constraints give you, is the ability to write a constraint like that. So that's quite new. Give it a go if you've not come across them. There's plenty of raw material. There's the wiki page about it has pointers to blog posts written again by Ryan to explain why this is actually something you might want. At ICFP last year, I remember having a conversation with Iceland Jack, whose real name is Badur. Yes, and he and Ryan again. Wrote a paper about this, which is actually at the Haskell workshop this year, Haskell Symposium this year. So and it's fully implemented. It's in fact, it's in GHC 8.6, just come out. Yay! It's super cool. Matthias, are you here? Yes. So we, having started with this idea of that if you write an underscore in your program, rather than saying bad programmer, we might say, oh, there's this little hole in, there's this little hole in your program, and you might, never mind, I can improvise. And you might want to, oh look, there we are. And we'll tell you what type it is, but Matthias's new piece is to then say, and here are some things that might fit in that hole, including these that are more polymorphic. So if the hole is a type int, then I'm not sure it's very helpful in this particular case, but max bound, even though it's more polymorphic than an int, is something that would fit in that hole. So that's quite nice. And I think there's quite a lot of people. Hands up if you actually use holes, sort of routinely. Wow, look at that. Isn't that amazing? I don't know these things because all I get is the bug reports. So that's good. So holes are, and was it you first suggested holes as a reportable thing?
No, that was before.
It was another research student. That's right. Austin, maybe it was Austin, but it was another Swedish research student, I feel. Anyway, he left me with a huge pile of both. Now they've sort of. Oh, that's true. Anyway, what tends to happen is that somebody implements one of these things and then goes off and gets a real job, and I get left fixing the thing to make it work. But Matthias has stayed the course. Well done. Yes, so lessons for all of you. I want to say a tiny bit about the type-in-type consolidation, because I see this as being quite a significant, long-term thing that GHC is becoming more and more dependently typed. We're moving quite slowly, but the type-in-type step was really just saying, look, let's make types and kinds be the same thing. So Stephanie and Richard sold this to me very seductively, How could it be types and kinds? It makes the GHC simpler if they're the same, right? Why make these artificial distinctions? And I'm thinking, I'm going to stay away from types and terms being the same thing, but types and kinds, well, in GHC, they're already represented by the same set. And I thought, cool, right? And it's taken 2 years just to settle the dust. Lots of bug fixes and some fairly significant internal changes. Right, so in the last few months, the flattener, those of you who, I'm not going to really explain what these things are, but these are internal engineering things in the type checker. Quite significant systemic changes have taken place. And Ning Ning, are you here? There's Ning Ning, is going to be giving a talk later in the, today about coercion quantification. And it's also, this same stream of work has led to some significant language visible things. These things are not really visible to the programmer for the most part, but there are some significant language visible Haskell proposals that have bubbled up. Type level kind signatures, this is really, at the term level, you can write a separate type signature for a function. So at the type level, you should clearly be able to write a separate kind signature for a type. And that would sweep away an immense pile of dog poo. So that's, I think that's likely to happen. We need a way to write, we need syntax for writing dependent kind quantification. So what does that mean? Well, that means if you've got this data type F, which has this higher kinded F guy here, right? So he's of kind, this F chap is of kind K to type. A is of kind K. So T's kind is for all K, that's the A, K to type, that's the F, and it returns a type. So that's fine. But what happens if you wanted to mention K as an explicit argument rather than a sort of secret one? Because really K morally has a T here morally has a K argument. It's just invisible, like the for all types are invisible at the term level. You don't write explicit type applications. But if you wanted to make the K explicit so that every use of K in your types, you are going to mention the kind explicitly, then how do I write the kind to make that clear? Because remember, looking at the kind signature alone, we want to know how you should write types that mention it. We don't want to have to look back at the definition to see. So we need a notation in types and kinds, they're the same thing, remember, that lets you make a distinction between this kind of binding of K and this kind. And that's a proposal that's coming along. Here's another one. Just as we got visible type application in terms, we're going to need visible kind application in types. That's sort of, so you can see how we're just sort of filling out the box, just making everything sort of simple and uniform and, okay, what did you do last time? Oh, okay. Oh, there we go. Well done. Yes, good. Okay, so these are the dramatis personae. So Richard is, sort of Stephanie is the sort of great granddaddy, as it were, of all of this, a great grandmother. And Richard is her acolyte, but now turned dependent type devotee. So Richard is really hugely responsible for making all this fit together well. Richard and I have a weekly phone call at which we try to keep each other sane. Ryan, you've done a tremendous amount in this, and in particular on reporting bugs. Ning Ning and Me is here too. Been doing stuff here as well. So I'm really grateful to all of you. It is quite a big project, and I think there's quite a lot still to do. I want to say this isn't just tidying up. There's some substantial intellectual pieces to be done here. It turns out it's not routine. So, There you go.
So does
Yeah.
this mean that at the pipeline level,
Yes.
that Haskell is just sort of like admin now, independently typed language?
Yes. Yeah. No. Wiggle away. Now I forgot, but the trouble is I've now forgotten what I was going to say next. Wiggle. Yes. Well, I don't know. I can look at this. Yes. What's cooking? What's going to happen in GHC 8.8? So we're doing lots more work on performance. This is probably, everybody wants particularly compile time performance. Everyone wants the compiler to, programs to compile faster. Hadrian, is any Hadrian, Alp's not here, is he? No?
No.
Hadrian is GHC's new build system written in Haskell. And we keep saying it. This time last year I was saying, it's going to be really, really ready soon. And now it really is going to be ready soon. Arno, are you here? Arno and his colleagues at Twig have been working hard on this extension for linear types. This is I've got a little bit more to say about GHC proposals in a second, but there's a talk about that later. Kevon's not here, is he? Oh, Kevon, you are here. Right, so I want to ask you about how is this going? Oh, it's gone. I desperately want, CPS calls in LLVMs. That would greatly improve our backend. And Simon, is anybody working on mutable constructor fields actively? Anyway, so this is a thunk. There's a sort of accepted proposal, but it needs some implementation work. I did, right. but I'm no longer the supreme dictator. No, you don't look away, Ben. Every time you look away, it goes off. Where were we? So another ongoing thing is Cheyenne Najd and Alex Zimmerman's work on called Trees That Grow is the generic title, but the general idea is let's take this huge data type that represents Haskell terms, and instead of having a GHC specific one, let's have a GHC independent one and use it for, just as a Haskell library, use it for GHC and for template Haskell and for Haskell source texts. So that's the sort of vision, but then it turns out because it's a very big data type and there are lots of different requirements on it, there's quite a lot of wiggling about to make that work, and also because it's big and is deeply embedded across GHC, it's not a simple change to make. So it's slowly coming along. Thank you to Cheyenne look, there we are. Cheyenne and Alex for that. Another big thing that has happened in GHC and is continuing to happen is Backpack, which I'm just going to let Edward give a sort of quick update on Backpack, because I think it's extremely cool and big.
All right, thanks, Simon. So basically, if you haven't heard very much about Backpack, that's because you haven't been listening in the right places. So, Backpack is in GHC, like you can use it, it's in Cabal, and it's not in Stack yet, but more on that very shortly. And there's some really cool things that people in the community have been doing. So HaskTorch, everyone's all agog about deep learning. Well, HaskTorch is a deep learning library, written in Haskell using Backpack because you've got all these tensor types, you've got all these numeric types. You want to keep them straight. Type classes are very annoying for that. There's also is Edward Komet here. He's outside. He did this wonderful library called unboxed containers, where you can take your data map and just pack the key in, so you don't actually have to pay for the indirection. Lots of performance you can get from that. And there's also another one which is basically just backpackifying containers, and that one is that was from Dimitri. I don't know. Are you here as well? No. Okay, so what about package manager? So I mentioned Stack, so let me just jump to Stack. So Stack is apparently going to be embarking on a build refactor. Michael Snoyman is working on this, and hopefully they're going to make some changes that'll make it a lot easier to implement Backpack in it. There's also Francesco Gazzetta, who as part of a GSOC project was working on adding support for multiple public libraries in Haskell packages. So this is, you have a single Cabal file. Oh, Yes. I was like, one slide, easy. And you want to have multiple libraries from it. And so what's next? Well, not too much. A little bit of cleaning up, and like make sure I write the paper because I really need to write a paper and submit it somewhere.
Write the paper. All right, here you go. Okay, so Ben, you're up.
All right.
Backpack is a ML-style module system for Haskell developed by Derek Dreyer, Simon Hayden-Jones, me, and Scott Kilpatrick, and it is cool. It uses mix and linking.
It's mixing style rather than L style.
Right, okay, so I guess we'll have to do this without the benefit of slides this time. So this year, we finally took a concerted effort here at GHC HQ to actually really take a hard look at our continuous integration infrastructure and get serious about testing. And this has been with the help of a whole bunch of people. So Twig.io has been incredibly supportive and helped us get sort of a nice CircleCI and AppVeyor-based infrastructure up and running. We have financial support from Google X, so they really deserve a quick round of applause if that's good time. And so the goal here is to really be I'm sorry? Yeah, and we've, a whole bunch of individuals have been helping to push this along. Davian has been helping with getting the machines and try to organize infrastructure. So there are really a few goals here, and we really want to try to reduce the release friction. So now we have the 6-month release cycle. It becomes imperative that we try to get that friction down as much as possible, because we have relatively few resources to do these 6-month releases. So we're trying to reuse off-the-shelf infrastructure wherever possible. That led us to AppVeyor, CircleCI, and we want to be much more thorough in our testing. So we don't have, like it has happened almost every release in the past 3 years, some late-breaking regression that we get notified of, 3 weeks before the final release deadline. And then we have to stall the release, and that's indeed what happened to 8.6. So we're really trying to be more thorough. Nightly regression tests using all of the slow validation tests. And that's a huge task because most of these, at the beginning of this year, we had over 800 failures in the slow validation way, I think, because it was very rarely ever tested. So there's been a lot of work in trying to fix this. Alp has been, Meskin Larry has been really doing some great work on this. 8.6, we've made some great progress though in the last year. 8.6 is the first release, which has been released. The release artifacts have been almost exclusively built using continuous integration infrastructure. So we're making progress there. We have a lot more remains to be done though. So we need integration with Fabricator. Working with external providers like CircleCI is great. They manage a whole lot of the infrastructure that we would otherwise need to manage, but there's also some challenges there. They only support GitHub. So if we want to keep Fabricator, that requires a bit of work on our end. That's actually something that's been done. We're now waiting on deploying that until we move our infrastructure away from to a new hosting provider. But there's still more work to be done cleaning up our test suites. And we really want to ultimately to end up in a situation where every commit rather, has a full test suite validation run before entering master. So we know for certain that we aren't going to be sort of responding reactively to these regressions. And that will make things much easier for everybody involved, remove a whole lot of headaches from the overall, yeah. So I think we may be running low on time though.
Yep. So this is. I just wanted to finish with to say just a tiny bit about the community. That is all of you, because this is what makes GHC tick, right? So. Everything's going quite well. GHC is really flourishing. There are more and more contributors, and it's more and more of a sort of diffused leadership model. So I really like that. In the last 12 months, we had 109 different authors writing commits, 65 of whom did so for the first time. I think that's amazing. This is really a lot of lines of code added, and really a lot of new tickets. Here's some graphs about new tickets. So let's see. This line is the number of new tickets in any particular year. So you can see the rate of submission of new tickets. This is, things that are not going well is climbing. Right? The closed is, was keeping up for a while because let's see, open, that's this blue line. We were kind of doing well here. We're more or less keeping up with the floodgates. But this is not, so we need your help, right? The blue line going high is not good for, really. More open tickets, yeah. We have 2,000 open tickets. I mean, of course, some of these are, what an open ticket means is a, but doing something about this would be great, and that means more people helping, right? So it is a... Ask that again? Why is open growing faster than new? I have no idea. Oh, this is... Right, new is a rate, yes. And open is a... But nevertheless, it shouldn't grow faster. Yes, it should. I'm going to move on quickly. So there's a core team of people who do actually have as their day jobs working on GHC. This is a change from 10 years ago, and this broadening here is a change. Facebook and IOHK have joined Microsoft in actively funding GHC maintenance and developed. And Well-Typed themselves, though these guys often mostly work for Well-Typed, are giving us an extremely advantageous rate. So in effect, they are significant contributors in their website. Thank you to all of those people, but also to all of you who are contributing on a daily basis. That is one new thing that happened a year ago was the GHC proposal process. I thought you'd give you some figures about that, because I think this is going quite well. Last year we had 30 open proposals and 41 closed. This year I had 151 proposals total have been, this is language change proposals, have been put forward. 34 of them are still under discussion. 10 of them are in the committee's purview at the moment. 127 have gone away altogether, and 33 have been accepted. So it's been quite a significant source of language innovation. I think it worked really quite well for small proposals. We're struggling a bit on big ones like the linear types proposal, because it is so big. And I'd like to say thank you to Joachim for being a really good secretary. You have been doing an amazing job. Don't forget the DevOps group, which we announced last year. This is people who care about actually making the mechanics of making into GHC a reliable artifact that you can use for mission-critical work. If you're a person for whom that's important, or your company is, talk to Manuel Chakravarti, who chairs the DevOps group. That sort of has led to the continuous infrastructure stuff. Let's see. This is mostly about just saying, this is an open source project. It does rely on all of you, essentially. If you all just fold your arms and wait for Ben to do something, Ben will just get overheated and blow a fuse, and good things will not happen. So please join in. Any other questions, observations, ideas? So this has been a bit of a race through. That's extremely unusual.
Who use not lists, because there's a
Oh, yeah.
hard-time fact that I'm one of the more max-related people who occasionally micro helps on GHC, and I barely understand OSX. So, there's always room, especially with Vol and all these other tools, there's always enough attention on Linux. Simon's usually the one who knows.
Yeah, I discover all the bugs in Windows. Why is that?
But whatever your personal favorite OS is, just building it and see if you can get all to run often can result in a good particular thing.
Yeah, I agree with Carter. I moved from OSX to Linux. I didn't have to worry about dynamic linking anymore.
But also the important thing that actually really helps it for the first computer is saying you don't have to understand to pick a thing and zoom in on it, and just first do a thing, focus on a subsystem. There's too many parts, and each one you get each.
And there's a zillion ways to contribute, like even providing well-characterized bug reports, not just, GHC didn't work on my enormous application, but I've taken some time to boil it down. That's incredibly helpful, and also makes it much more likely that we can fix things. So there are a lot of ways to contribute. Okay, I don't want to steal somebody else's time, so how are we doing?
No, that's probably fun.
Yeah, cool. So be empowered.
Thank you, Simon. Okay, I'm going to defeat the ghosts of this presentation system to give my talk now. That's the first step, okay.